Hi guys, this is Mrs. Cornett, and I am going to make another video that goes along with some topics from section 7.3. In order to find least common denominators, you really need to understand the concept behind finding common multiples, especially least common multiples. And so that is what this video is all about, finding the LCM. Okay, LCM stands for least common multiple. And there's an example on the right side of the screen. Find the least common multiple of 8, 4, and 6. There's the number 8 and this arrowhead, and the multiples 8, 16, 24, 32, 40, 48. And then the next row is the number 4. The arrowhead is pointing to the multiples of 4. 4, 8, 12, 16, 20, 24, 28, 32, and then the same for 6. The concept of least common multiple is what is the smallest multiple that is found in each of those numbers' list of multiples. And so as you can see, there's a little orange box drawn around the number 24. So the least common multiple of 8, 4, and 6 is 24. In this video, I want to show you a method of finding least common multiple using a factor tree. If you take a look at number 3, you're asked to find the LCM of 15 and 6. So the way I would like to teach you is to first find the prime factorization. Prime factorization means to make a factor tree, and that bottom list of numbers from a factor tree is called the prime factorization. So if we start with 15, it's 3 times 5, and 6 is 2 times 3. So the prime factorization of 15 is 3 and 5. The prime factorization of 6 is 2 times 3. Okay, next, here's how we're going to find the LCM. We're going to first identify each unique factor from the two lists of prime factorization. For example, when I'm looking at both prime factorizations of 15 and 6, I see a 2, a 3, and a 5. I don't see any other numbers outside of 2, 3, 5. And then we're going to go back and figure out how many times that particular factor of a 2, a 3, or a 5 shows up in one of the prime factorizations. Okay, so the factor of 2 only shows up once, and so I'm just going to write it once, is a 2. 3, both of them have a 3, but for any one prime factorization, that factor only appears once, so this is also going to be a 3, and then the factor of 5 only appears once. I'm going to take all of these appearances, 1, 2, 1, 3, and 1, 5, and multiply that together. 2 times 3 is 6, and then times 5 is 30. And so the LCM of 15 and 6 is the number 30. 27 can be broken down to 3 times 9. We'll bring the 3 down because that's a prime number, and then 9 is also 3 times 3, so that's the prime factorization of 27. 18 is 2 times 9. 2 is a prime factor. 9 can be broken down to 3 times 3. Okay, so the same question, and it's kind of a strange question, but what are the unique factors when you're looking at both prime factorizations? The only numbers that show up are 2 and 3. Now if you go back and look at these prime factorizations separately, what is the most time the factor of 2 shows up? Well, it only shows up on the factor tree 18, and it only shows up one time. So I'm going to write the number 2 one time. Next, which prime factorization has the most 3s? Well, it's 27. It was all 3s. And so I'm going to write down all 3 of those 3s because that's the most 3s. 3 times 3 times 3. Once you have finished with that list, you're going to multiply all of those numbers together. So 3 times 3 times 3 we know is 27. And then 27 times 2 is 54. And so the LCM of 27 and 18 is 54. Okay, let's look at some of these because now we're into some variables. Take a look at number 15. We're still looking for the LCM. This will be of 20y and 14y squared. 20y breaks down to 4 times 5. 4 breaks down to 2 times 2. And then we'll lower the 5 down and go ahead and write the y down in the list of prime factors. 14y squared is 2 times 7 times y times y. Okay, so the first question, again, it's kind of a strange question, but what are all the unique factors found in either one of these prime factorizations? We see 2's, we see 5's, 7's, and y's. Now we're going to go back to each of those factors and determine at most in a single prime factorization how many times does that factor appear. Okay, go back to the factor 2. It shows up only one time in the prime factors of 14y squared. It shows up 2 times in the list of prime factors of 20y. 2 times showing up is more than 1 time, and so the most a 2 shows up is twice, so I'm going to write 2 times 2. 5, the most a 5 shows up is just 1 time, just shows up in the list from 20y. 7, the most 7 shows up is once, and y, the most the factor of y shows up is it shows up twice in the prime factors of 14y squared, so I'm going to write it twice. Now I'm just going to take that information of how many times that factor showed up. Those are the numbers that I'll multiply together to get the LCM. We'll have 2 times 2 times 5 times 7 times y. So the LCM of the numbers 20y and 14y squared is 140y squared. 17, we have 32u squared and 14v squared. 32 is 8 times 4, which that breaks down to 4 times 2, which break down again to 2 times 2 times 2. The 4, I'm going to bring it all the way down because it breaks down to 2 times 2, and then I'll put the u times u. That's the prime factors from 32u squared. 14 is much shorter. It's 2 times 7 times v times v. Okay, next is the list of unique factors. We have 2's, 7's, u's, and v's. Both list of prime factors has 2's, but the one that has the most has 5 2's. And so we'll do 2 times 2 times 2 times 2 times 2. Or you could do 2 to the 5th, it's fine. The most 7 appears in one prime factorization list is once. The most u appears is twice, so that's u squared. And same with v, it appears also twice. And so now we're going to multiply each of these numbers together. We know 2 times 2 times 2 times 2 times 2, that's a mouthful, is 32. And so now we have 32 times 7, which is 224. And so the LCM is 224 u squared v squared. Take a look at these problems. I will not do all of them. These are the ones that I took a screenshot out from your book. So take a look at 23, 9y squared, and 12y. 9y squared is 3 times 3 times y times y. 12y is 4 times 3 times y, but then go ahead and break down the 4 to 2 times 2. So our list of unique factors, we have 2's, we have 3's, and we have y's. The most any list of prime factors has 2's. It shows up twice in the prime factors of 12y. 3's, 3 does appear in both lists of prime factors, but the most that show up in a single list of prime factors is 3 times 3. It shows up twice. And the most that a y shows up in the same list of prime factors, it shows up twice. So it's y times y. Now we'll multiply those numbers together. 36. Y times y is y squared. And so the LCM is 36y squared. Look at 25. You have 2 times the factor y minus 3 and 6 times the factor y minus 3. It looks a little harder when you have binomials, but it actually isn't that bad. This one's just going to separate into 2 times y minus 3. This one will separate into 2 times 3 times y minus 3. And then do you see the unique factors are a 2, a 3, and then the binomial y minus 3. A 2 shows up once, a 3 shows up at most once, and y minus 3 shows up at most once. So we'll multiply those together to get 6 times y minus 3. I think WebAssign would also be okay if you multiplied that 6 through to get 6y minus 24. Okay, take a look at 27. It's 16x and then 12x times the binomial x plus 2. 16x is going to break down to 4 times 4, to 2 times 2 times 2 times 2, and then times x. That's the list of prime factors. 12x breaks down to 3 times 4, 4 breaks down to 2 times 2, and then you have the binomial x plus 2. So your list of unique factors is we have 2's, we have 3's, we have x's, and the binomial x plus 2. Now going back to these prime factors, the most times the factor of 2 shows up is in the first list of factors from 16x, and it shows up 4 times. So I'm just going to write 2 to the 4th. Okay, next, the factor of 3 at most shows up 1 time in a single prime factorization, so we'll write 3. The most x shows up. Now this is a single x. This is not the x that belongs with x plus 2. That shows up 1 time, and then the binomial x plus 2 shows up 1 time. Okay, now we'll multiply these together. We know 2 to the 4th is 16. 16 times 3 is 48. And so the least common multiple of these two numbers is 48x times the binomial x plus 2. Take a look at 31. We have 3 different numbers. We have x plus 2, x squared minus 4, and a single x. X plus 2, there's no way to break it down. It's just x plus 2. We can break apart x squared minus 4. That's a difference of squares. And so we could say the binomial x plus 2 and the binomial x minus 2, and then x, it cannot break down. Here's our unique factors. We have a binomial x plus 2, we have a binomial x minus 2, and a single x. X plus 2, at most it shows up 1 time in a single list of prime factors. So we'll have an x plus 2 as part of our answer. X minus 2 at most shows up 1 time in a single list of factors, and so does x. And so when we put all that together, the single x will go first. X plus 2 times x minus 2. You can leave it like that in WebAssign, or you can go ahead and multiply it back out to x times x squared minus 4. Number 30 is x minus 1, then you have a single x, and then you have 2 times x plus 3. All of these are as simplified as you can get them. Like you can't, I mean, we can break this one into 2 times the x plus 3, but we don't really need to make a factor tree. Do you see the individual factors are the binomial x minus 1, the single variable x, the single number 2, and the binomial x plus 3. And you see at most in a single list of prime factors, they show up only 1 time. And so the LCM is going to be a combination. The LCM is going to be all of these numbers together, which is 2x times x minus 1 times x plus 3. Again, you can leave your answer just like this, or you can multiply that through, but this answer should be fine in WebAssign. Okay, so this is not an easy topic, especially some of these harder ones are really forcing you to think outside of the box, but practice this, go back and review this video again, reach out to me, ask me questions. I can do some more examples with you, so just let me know what you need.